Hello all, in today's lecture we'll be solving some few problems based on combinational logic circuit, and we'll also see how to design the combinational logic circuit for the given statement problem. Clear? This is how your question will be. Read out the question. Design a combinational logic circuit. They are asking you to design. Design meaning finally they are expecting a logical circuit diagram. They are asking you to implement whatever expression, final simplified Boolean expression you have got. They are asking you to implement that using logicals. That is the meaning for the word design. Clear? Design a combinational logic circuit that has 4 input. So, you know, for 4 input, how many combinations are possible? 2 power 4, it is 16. That is from 0 to 15. Right? This is my input. Your first step has to be to read out the statement problems, and the second step has to be to identify what is my input variable and what is my output variable. And after identifying, you have to take it to a truth table. Now, draw the truth table. I know about the input, that input has got how many variables? 4 inputs. So let me take the variables for all the 4 input as, let it be A, B, C and D. Right? For 4 input variables, how many combinations are possible? We have got 16 combinations. That is, it starts from 0 to 15. So write down the numbers in binary. It is 0, 0, 0, 0. Write the equivalent decimal also. So I've written all the 16 combinations here. I'm done with the input now. Now identify what your output is. Read out the question now. This has got 4 input. We are done with the input, and it will produce and 1 output. So you have got only 1 output. But what is the output? They have not given it directly. They have given a clue for you. Read it out. The output will produce a 1 when the input is greater than 1000. What does it mean? Where you have 1000, 1000 is at the number 8. So all the numbers that are greater than 1000 will have my output as 1. Clear? All the numbers, this is what has been given. You will produce an output 1 when the input is greater than 1000. Greater than or equal to is not given. It is, they have just mentioned like greater than. So 1000 you cannot include. All numbers greater than 1000, you have to include only those numbers. So what are the numbers which are greater than 1000? 1000 is pointing to number 8. So all the numbers that are greater than 1000 is from 9 to 15. All these numbers starting from 9 to 15, you will be having your output as 1. Clear? What about the remaining numbers? They will be having your output as 0. Clear? Now, you have got your output also now. We have done with the input, we are done with the output. What is the next step? Whatever output you have got, take that to a K-map. How many variables are there? You have 4 variables. So, which variable K-map you will be taking? 4 variable K-map. Variables are, it is C bar, D bar. Default it is SOP I told you. So, as per SOP, we very well know 1 is represented with the actual variable and 0 is represented with the complement of that variable. Clear? So, the first variable corresponds to C and the second numbers corresponds to D. In a similar way, here again, all the first number corresponds to the letter A and all the second numbers corresponds to the letter B. Fine. Based on this, you will be writing the variables. Here it is 0, so I have given C bar. First number corresponds to the letter C. So, all the first numbers you have to write it as per this. Here the first number, it is 0. So, 0 meaning it is C bar. I am writing the first number alone. Here it is 1. So, it will be C. Here again it is 1. The first number will be C. Clear? The second numbers all corresponds to D. So, wherever 0 is there, represent that with a bar, and wherever 1 is there, you have to mention that as such. Clear? Here it is 1. So, it is D. Here again 1. It is D. Here again it is 0. So, I will be mentioning that with D bar. Clear? In a similar case, right, for A and B also, here it is A bar. All the first variables corresponds to letter A. Let me finish off with the first variable. Here it is 0, so it is A bar. Here it is 1, so A. Here again 1, it is A. Now, let's find out for the second variable. All the second numbers corresponds to the letter B. So, if it is 0, you have to represent that with a complement. So, it is B bar, B, B and B bar. Is it clear? Now, fill out the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. By now, you should be aware of how to fill out the numbers and how to do the mapping in the K-map. If you're still not confident, refer to my K-map lecture. It's a complete video of how to do the K-map, how to do the positioning, mapping, and how to derive the Boolean expression. Everything base level it has been given in that lecture. If you want a base strong on K-map, kindly refer to that lecture. Those who have not seen that lecture, I'll give the link of that lecture in the description. Kindly refer to it before coming here. Clear? Now, fill out the numbers. Where all 1 is there in the output, you have to put 1 in the K-map against those numbers. Now, where do you have 1? All the numbers that are greater than 8. That is from 9, 10, 11, 12, 13, 14, 15. All these numbers has got your output 1. Fine. Only the output you have to take it to your K-map, not the input. Clear? Now, where do you have 1? From 9 to 15. So, check out the numbers. 9, 10, 11, 12, 13, 14, 15. Only these numbers has got 1. Right? Only the numbers wherever you have got 1, only those numbers you have to fill it in the K-map. And where do you fill? Against these decimal numbers. Is it clear? Now, do the mapping. This is one map. This is another quad. And here you can do another mapping. Clear? Give me the expression. For the first quad, give me the expression on the vertical, which is common. Here A is common. And on the horizontal, which is common, D is common. Right? Now, check for this quad, which is common here. A is common. And check on the horizontal, which is common. C, first number is common. So it is C. Now, check for this particular pair. Here, which is common, AB is common. And on the vertical, C bar is common. Clear? This is the final simplified Boolean expression for the given statement. We are not done with the problem yet. We still have to design what they have given. They've asked you to design the combinational logic circuit. What does it mean? Whatever final simplified Boolean expression you have got, you have to implement that. You have to design that using a combinational logic circuit. That is using logic gates. Clear? Now, this is a product term. So, for product term, which gate you will be using? For product term, you will be using AND gate. And for sum term, you will be using an OR gate. Clear? And for complement, you will be using NOT gate. Fine. Now, this is a product term. A and D are a product term. That is a min term. So, if it is a product, so which gate you will be using for product? AND gate. And what are the input for this AND gate? A and D. A and D. These two, I am giving it to an AND gate. What is the output of AND gate? AND gate, it is a product term. So, whatever input is given, that input you will be getting it on the output as a product term. Clear? Now, go for the second term, A and C. A and C is again a product term. So, for product term, again you will be using a AND gate. So, A input, C input. These two are my inputs. What will be the output of a AND gate? It will be the product of whatever input has been given to that gate. Here we have A and C as your input. So, A and C will be the product of A and C will be your output of this AND gate. Clear? Now, the third min term, it is A, B, C bar. You have three terms. One input is A, the other input is B. The third input, it is C. But here C, you have a bar. What does it mean? It means complement. So, for complement, which gate you are using? You are using a NOT gate. So, the first step has to be to convert C to a complemented form. So, give your input to NOT gate and then the output of NOT gate, it is the complement. So, do that. Now, all these three input, A, B and C, all three together are in product terms. So, for product, which gate you will be using? AND gate. So, all the three input, give it to an AND gate. Clear? So, what is the output of it? Output of AND gate is a product of all your inputs. Right? Product of your input means what are the input? You have got A input, B input and C bar. C has been converted here, so it is C bar. So, A, B, C bar will be my output of this AND gate. Clear? Now, all the three AND gates. This is one AND gate. We have got, this is another AND gate we have got. Here again we have got another AND gate. All the three AND gates, what they have done? They have summed up. For sum, which gate are you using? You will be using OR gate. So, the output of all the three gates, you have to take it together and then give it as an input to your OR gate. Clear? This will be your final design of your combinational logic circuit for the given statement. Is it clear how to design a combinational logic circuit using logic gates for a given statement? Let me sum it up. Whatever statement is question has been given to you, read the statement very slowly and try to split the question so that you will understand better of what is being given in the question. What is your first step? They are asking you to design a combinational. Design in the sense they are looking for a circuit diagram. Fine, using the logic gates. Now, what is the second step? It has got 4 input. They have given you 4 input. Now, for 4 input, how many combinations are possible? We know that. For 4 input, we'll be getting 16 combinations. So, draw a truth table, write down all the 16 combinations. Clear? Now, with respect to output, what they have given and 1 output. So, you'll be getting only 1 output. But what is that output? They have not directly given. They have given a clue for you. The output will produce 1 when the input is greater than 1000. What is the number against 1000? 1000 is against number 8 in the decimal. Fine. Whatever number that is there greater than 1000, those numbers you will be having your output as 1. Clear? Now accordingly write the output. After finding the output, now we are done with the input, now we have got the output also. After you're done with the output, whatever answer you've got in the output column, that column you have to take it to your K-map. Clear? After taking it to a K-map, do the mapping, get the simplified Boolean expression. After getting the Boolean expression, try to design it using the logic gates to get a combinational logic circuit for the given state. Is it clear? I hope you are clear with how to design a combinational logic circuit. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.